I just got my hands on the brand new ChatGPT agents, and I have to say, I'm kind of impressed. It's not just answering questions anymore, it's actually helping you getting things done. You give it a go, and it figures out how to get there, whether that means creating a plan, running tools, writing code, or asking you smart follow ups when it needs clarity. So naturally, I wondered, could it actually build a financial model? Because let's be honest, the dream that everyone has is that AI will come and with a simple prompt, hit enter and boom, a fully functional, dynamic, integrated model just appears. Can AI actually do that? I decided to test. Let's start with some definitions, just so we are on the same page. A ChatGPT agent is a goal-oriented system that can take an objective, decide how to approach it, and then execute across multiple steps, often using external tools, data, or code to get there. Think of the agent as the brain. It plans, it reasons, makes decisions, and manages the overall flow. But it doesn't do everything by itself. That's where operators come in. Operators are the tools the agent can use. They're like function blocks. Each one does a specific thing. Run a Python code, open a spreadsheet, generate a chart. They're powerful, but they're kind of dumb. They don't initiate anything. They just respond when they're called. The agent decides which operator to use, when to use, and how to combine them. So if you say, build me a revenue model, the agent might call one operator to generate the skeleton, another one to calculate assumptions, another one to format the output, and another one to run a sensitivity analysis, for example. All coordinated in a logical flow. This separation is key. It makes the system modular, which means it can scale and improve over time without breaking everything. And it also means you can customize it, even build your own operators to plug into agents' workflow. So when people say agents are smarter, that's not just hype. It's a structure. It's orchestration. And now that we know what's under the hood, let's get to the question. Can it actually build a real financial model? So let's test it. I'm here on my ChatGPT account and I go here on agent mode. And that's where I'm going to paste my prompt that I have already written so it doesn't take too long. So here's what my prompt says. It says, you are a financial modeling agent trained to analyze and forecast the revenue of a subscription-based companies using driver-based logic. Task. First, I define who I want the agent to act like, and now I'm going to give the task. The task I gave to my agent was create a quarterly revenue forecast for the company Rent the Runaway based on the historical data and a driver-based approach. Context. Use marketing expenses as the primary driver for both ARPU, average revenue per user, and number of subscribers. Recognize the marketing spent typically affects number of subscribers positively and ARPU negatively due to discounting and acquisition costs. You may propose alternative or additional drivers only if they improve the forecast accuracy. So I'm giving it how I want it to be analyzed, even if it's wrong, but I'm letting it to think about it and maybe propose another way to do it if it's the case. For simplification, focus on total revenue only. Ignore revenue breakdowns such as subscription versus other services. Output format. So I'm now determining to the agent how I want to see this analysis. And I'm keeping it very simple. List and define our assumptions and driver relationship. Show a table with the historical quarters and forecast quarters the next 8 quarters. Marketing expenses, ARPU, subscribers, and revenue per quarter. Output a downloadable CSV. Noted that I didn't ask for a model now. I just asked for the analysis. That's the first step. Briefly explain trends and key insights from the forecast. And optionally, if it's possible, if it's feasible, include a sensitivity analysis. So that's the prompt that I did. Let's see how it goes. So you see now, after I hit enter, it starts to sync. And it tells me it's going to their own desktop. So what it happens is it has a virtual machine, but it has a user interface here. It has a graphic user interface. So I kind of have a look on what it's doing, what kind of article it's reading, what pages it's going. I don't look exactly how it looks on a virtual machine, but it's a simulation of what it's seeing, if it's reading, if it's writing code. I can see everything. And it's executing some code to create exactly what I asked it to. So now here's the result. So what I have here, I have the assumptions and the driver relationship. And let me see how it looks. It says below the quarterly revenue model and forecast for the runaway based on historical results. And it says the assumptions, the driver relationships. And you can see here that it has also the links to the sources, which is a good thing. If I want to check what it's talking about, I can go there on the links. And it shows the logic on the driver. So that's something that I asked it. I asked it to marketing expenses influence both number of subscribers and average revenue per user. And it's doing just that. And it's telling me that it did a linear regression on the historical data. And it's suggesting that this is the number of subscribers that it adds for each dollar, if each million spending marketing. And it also reduces ARPU by 6.32. The base levels are about 124 subscribers and 618 ARPU. So it's doing a good job in following my instructions. I was specific to say what marketing expense should drive, and it did just that. It used it exactly that. Now, if you see the forecast plan, it shows here also the marketing is assumed to follow a management plan. So it already saw on the reports that were released on the by the investor relations, what is the plan to spend on marketing on the next few years. And it used just that as assumption, which is also a good thing and saved me a lot of time in research. And the simplicity, it says that the model is ignoring the subscription, ignoring any streams of subscription revenue and skipping everything closed down on one line. That's exactly what I asked to. So if I open here the CSV, let's see how it looks like. So let me open the CSV, and here we go. So let me just make those columns a little larger. So it's just giving to me the quarter, marketing expenses, the number of subscribers, the revenue, and the ARPU. So it doesn't do a big deal, but it does exactly what I asked it to. Of course, I didn't go and recalculate those numbers to test if the model is doing a good job or not, but I'm pretty happy with the results it gave me. It's a simple thing, it's a simple analysis. That's not a model yet, and I'm going to test it further. It's a simple analysis, but at least it's getting where I need. It's going and getting the data. It's bringing to an Excel sheet. It's doing the calculation. It's running some analysis according to what I ask it to, and using the specific instructions that I gave it. So I'm pretty happy with this kind of analysis. But now let me just push it through a little more. Let's try to ask if it can build an Excel sheet that is ready for any changes in assumptions, meaning I need to have the assumptions separate and all the forecast revenue to formulas. So in case I need to change any assumptions, I'll easily do so. And also, I need to present this model to management, so format it on a way that's visually appealing and using good visualization charts to demonstrate the revenue and the main indicators. So let's run that. So it's thinking. It's running some code, probably Python. And here we go. So let's download this spreadsheet to see how it looks like. Okay, so here we have, it's a very basic spreadsheet. It has some assumptions, it has the marketing expenses, and you see here, it doesn't have the values because it didn't enable editing. Let me do that. Once I do that, it shows all the values and the formulas, very basic formulas. I didn't expect anything different, but the visuals are not good at all. They look kind of simple, too simple. That's not the way I would do it. So let me ask it if I probably could create a full financial model from scratch with all of the schedules for Rent the Runaway. So let's run that. So let me see how this happens, if it's going to be able to create this. So it's setting up the desktop. Okay, so it seems like it's done the job. It completed what I asked it. It's here's the full integrated financial model, and it includes assumptions. It seems like it's just not enough assumptions probably, but let's open the model and see. revenue forecast, income statement, cash flow statement, balance sheet, and some charts. So I just did one of the schedules, but well, let's see how it looks like in the spreadsheet. Okay, so we have here the assumptions, the same that they had it before, the marketing expenses, some financial assumptions, COGS in a percentage of revenue. It's not actually calculating the costs. Everything is a percentage of revenue, which is not the best way to create financial models. It's too simplistic, but at least it's doing something. Interest rate, tax rate, okay. Working capital as a percentage of revenue, that's not probably not a good idea. And then it has the start for the balance sheet of all the accounts. It has the revenue forecast. It's just enabled the editing. So, and voila, there circular references. So it didn't manage to calculate without circular references. But let's see how it goes. So we have here the income statement, the cash flow, the balance sheet. I'm not going to go through all of those. Very simple chart. Now, after seeing how basic the output was, I started to wonder why I delivered something so simple. That's when I came across the framework published by OpenAI, and it helped everything click. I'll leave the link for you in the description below. So I came to this image right here. Let me scroll down so you can see. It has an image right here of single agent systems, and it helped me to understand how the agent framework works. It's simple but powerful. The process starts with an input, your prompt. That gets passed to the agent, which is the orchestrator, but the magic is what happens inside the agent layer. There are 4 key components: instructions. That's how the agent behaves. You can customize this to define how it thinks, how detailed it should be, and how you want it to act. And that's going to be in your prompt. Then it comes tools. This is where it gets interesting. These are the actual operators the agent can call, like code interpreters, web search, spreadsheet writers, or even your own custom APIs. Then it comes the guardrails. The guardrails are constraints that keeps it within safe and useful boundaries. Think of them as bumpers to make sure the output doesn't go off track. Then it comes the hooks. The hooks are what allows the agent to interact dynamically before or after actions, like checking inputs, refining outputs, or logging results. So before doing anything final, it would ask you to review and to tell if this is okay. So in my test, the agent chose a pretty simple tool to output the final model, which explains the basic table it gave me. That choice was not wrong, but it was limiting. And it shows why tooling matters. Because this system is modular and open, and you're not limited to what comes out of the box. You can build your own operators. You can shape the logic. You can teach it to model the way you would. And that's exactly what I want to test next. This is what Agent AI unlocks. Not just automation, but augmentation. It's the future of work. And I am really, really excited to see what it means for FP&A. In the next few weeks, I'll be launching Tactic Lab, a space dedicated to experimenting with exactly this type of thing. We're not just asking how AI can do things for us, we are exploring how to adapt AI to our workflows and how to understand business problems through the lens of financial models. We are not afraid of being replaced. We are here to evolve. We move faster, we get better. If that sounds like your kind of mindset, hit the link in the description to join the list, and you'll be the first one to know when it's out. Also, I'll be giving away early access to a few beta testers. Just check the box that says beta tester, and you'll be the first to hear when this is open. I'll see you in the next one.